Yeah, I'm going to talk a little bit about ICTs that are available for us I guess in general in EO, but because a lot of the projects we're working on right now are water related, so specifically to water as well. So that just to give a sense, sort of a high level talks just to give people out there an idea of the tech that is out there, what's available to them, and some of the lessons that we're learning as we're going along. So just the conclusions up front. No silver bullet or one size fits all. So if someone comes to you with some technology and says this is going to solve all your problems, all of your data problems, everything's done, it doesn't work like that. There isn't something like that out there. You need to understand your eventual use case. So how the system is going to be used before you start investing in it. So you need to understand that quite well. Otherwise, you're going to land up in situations where you're building up data sets or building systems in a certain way, and you invest a lot of money into that. And eventually, if those use cases or the way it's going to be used wasn't understood up front, that investment will be lost. One thing I can say, which is almost a silver bullet, is that you have to use your standards extensively to maximize your return. And it doesn't seem like that in the beginning, but our experience with it is the use of standards will maximize return, and I'll talk a little bit about that as well. And then the other important thing is there's a lot of components out there already, so you don't have to build these things from scratch. There's a lot of components off the shelf that you can get. Go and take these things, learn about them, and use them inside your systems. And that can really sort of bootstrap you. Okay. So let's start with the problem. And I think water sort of highlights this problem, and especially in the sort of projects we've been working in. What we find is that you've got a large number of scales. So you're talking from what we call sort of ex situ. So you've got someone going in and sampling in the water and taking some bacteria out and taking that back to the lab. You've got your in situ sensors, which are busy making observations in some sort of flow. And then you've got your remote sensing. So you've got all these different data types with heterogeneous scales, different temporal scales. So you've really got a lot of different types of data in the sort of water domain. And this all has to be brought together somehow. And so you're probably going to find that, well, I've got a little picture of an Excel spreadsheet there because for some reason our data arrives at us that way as well. And that's usually from the labs or something like that. And you'll have some shape files and rasters and a whole big mix-up of data all coming in. And this sort of has to be brought together somehow. And you need the right technologies and the right ways to present all of that, because each of them does have their advantages. I mean, Excel spreadsheets, their main value is that it's very easy for a scientist to get in there and start doing something with that data, as opposed to some or other NetCDF or something like that, where they have to have special tooling and stuff like that. So each one of these has their value somehow. Further problems. The way the data needs to be used. On the one end, I guess this problem's sort of a CSIR problem in one way, but I guess it's a more general problem. It's across any government department, is that you have scientific research on one hand, which wants their data in one way, and you have operational systems on the other hand. And the way those two have to be balanced and the way that the data is used is very different in those two systems. And you need to think about that. You need to think about if this is going to be used for scientific research, how are we going to structure this data? If it's going to be used in an operational system, how are we going to structure that? And then obviously increasingly require big data processing. So going beyond just the typical desktop, people are increasingly needing to move their data to high performance computing or some sort of very large database infrastructure. So that sort of issues are starting to come in as well, and you need the mechanisms to be able to transport that data. Okay. Yeah, I like that picture. I don't even know if it's relevant, but I like it. So this is the typical Earth observation, scientific research, scientist sort of view of the world. They need to discover data or generate the data. Then obviously once they've discovered that, so maybe going to a portal or something, getting hold of this data, they would then access it, usually downloading it off an FTP site or something along those lines. The next thing would be to do their analysis, pull it into R, pull it into MATLAB or whatever it is, into some GIS, do some analysis on that, and then eventually present that data. And that could be presented either as a social graph or some sort of nice picture or some vectors or something along those lines. What's important over here is that how you store your data has a major effect on each of these steps. So if your data is stored as vectors, there's certain ways that you can access it and discover it that are very different from the way if the data is stored in this big data cube. Trying to find inside a big data cube a subset of the data can be very, very slow, whereas where you've got that data stored as nice little neat vectors in a database, you'll be able to get to that, discover that data very, very quickly. But that slows you down a little bit later on because maybe what you're interested in doing some sort of processing on that data and you want to do it sort of in a item after item sort of fashion. And if that is stored in a nice data cube, you can get through that very, very quickly. But if it's in a database, you're going to find yourself stepping through it a lot slower. So you always have these sort of trade-offs that need to be made all along the way. And that's for scientists as well. Scientists have these sort of trade-offs. And obviously, coming down to your presentation, whether or not the data is presented as a nice big raster or neat little vectors, or is it a graph or something along those lines. So all along that sort of chain. But more importantly, it tends to be that everything's very data-oriented. It's all about the data. We've got the data, we transformed the data, we did this to the data, and we published the results in the data. Everything's really about the data and getting that little result out at the end that can go into some sort of publication or a single little graph or image that's the result of all of that large amount of work. Operational information systems. This is slightly different. So yeah, it tends to be that people are more process-oriented. They're more interested in the process that happens. I'm talking about things, for instance, where the end result is an alert that needs to be sent out, or an email that needs to be sent to someone, or a nice report that they get. So we're talking about, even though that scientific research fed into this, we're finding that over here, it's more about the process. It's more about getting all of that data, processing it very quickly, not doing some complicated analysis on it, just processing the data and then being able to disseminate that information. So it's not about how am I going to present it or this nice little graph, but it might just be about telling someone, listen, some sort of threshold has been met and we need to respond appropriately to a decision maker or something like that. So the end result, even though the same data drives these two different processes, the end results are very, very different what you're after. And that actually dictates a lot how the system is that you're going to build. So often we would imagine as scientists that what we're building for our research can just be moved across into an operational environment and used there, but that's not necessarily true. There's going to be a mechanism required to transfer the small amount of knowledge or that is that algorithm into a more operational system and allow for dissemination mechanisms within that. So there's certain things over here. I guess what I'm trying to highlight, the research versus operational, is that there is a link. The result of your analysis, this long process that you go through, eventually arrives with two parameters that fits the regression line. Basically, those two numbers is what we want to transfer across to the process. That's what's going to be used in an operational system. The whole scientific process of getting to those two numbers and the statistical analysis and all of that is sort of discarded, and they just take those two little parameters that you've discovered and move them across, and now they've got an algorithm, say, for instance. The same thing in terms of your publications, or you might come up with a really nice picture and go through this whole process of deciding how to represent it. All they want to do is take that across and email it off to somebody. So, the hard work that you've put in sort of gets smashed down into something that could just be fed out to the masses very, very quickly. But there is a certain portion over there, and obviously the whole issue of discovery and generation of data sort of falls away in operational systems. It's not something, they're not worried about discovering data. They're actually just worried about an informational product at the end. That's something that scientists concern themselves. But there is that portion around access that has some sort of overlap. So, to all of that was the problem. There are some solutions. I think the most important thing is to remember that ICT is an enabler, not an hindrance. So if you're feeling that the ICTs in your environment are hindering you for some reason, there's a problem. You guys need to take a step back, and you're using the wrong stuff. Okay, it's supposed to be helping. It's supposed to be making the job easier. Everything that happens there is supposed to be making things better. So, and because it's a technology, and because we've invented it ourselves effectively, we can. I mean, we've seen new technologies, Apples and what PCs used to be and what they are today, and laptops and stuff. You know, it's possible to make these things easier to use. I guess what this picture is really trying to get the idea out of here is that scientists want to focus on the analytics. And so by allowing ICT to be an enabler and allowing for new innovations in the ICT space, we can allow that to happen. We really want to allow focusing on the analytics to happen rather than you having to worry about what data formats and what way to present things and stuff like that. That should be offloaded to the ICT space.